Hello, welcome back to Learn Physics. In today's topic, we are continuing with the same chapter, Electrostatic Potential and Capacitance. So last class we learned about the electrostatic potential, energy, that one, and then capacitance also. Just an introduction I had given you. What are the electrostatics of conductors, and then capacitor, that just an introduction. Okay, so capacitance is the ability to store the charges, that is capacitance. Which arrangement we are using to store the charges is called a capacitor. Okay, capacitor is the arrangement to store charges, and capacity is the ability to store the charges, and it is measured in farad, microfarad, picofarad and nanofarad. All those things we explained, and this charge is directly proportional to the potential. So we wrote it as C equals Q by V. Okay, till there we learn, and how we can make a capacitor. Okay, how we can convert two conductors into this capacitor, that also we learned. Now we are going to study about what will be the capacitance of a parallel plate capacitor. Yesterday I told you parallel plate capacitor means it's two conductors parallel to each other. That is capacitance of a parallel plate capacitor. If it is spherical in shape, it is called a spherical capacitor, and if the conductors are in cylindrical shape, we will say it as cylindrical capacitor. It depends, okay, in which way it will be. Okay. So next is capacitance of a parallel plate capacitor. Capacitance of a parallel plate capacitor. Okay. So we are going to find out this parallel plate capacitor. So we are going to find out C equals Q by V. The C value only we are going to find out. So we need the Q and V. How we will do that? First, I am considering a parallel plate capacitor which is at a distance D apart. Okay, as I said in the last class, D will be very small as compared to the area of the capacitor. Okay, we will be considering the distance D as very small. It's very close to each other. Now here it is one end, it will be positive charge, other end it is negatively charged. This and all yesterday we learned how we are getting this and all. Right, so here see, this is positive and this is negative. So two plates, parallel plates are here. One is plus Q and other is minus Q. Okay, now what will be the electric field of a plane sheet? This is one plane sheet and this is another plane sheet. So electric field of a plane sheet, already we learned about that in application of Gauss law. E dot ds, closed integral E dot ds is equal to Q by epsilon 0, and sigma ds divided by epsilon 0 equals to E into 2A. Remembering, right? So one parallel plate, we are considering a parallel plate, and here one parallelopiped we will be considering. Remembering now? Okay, we will be considering a parallelopiped on both the sides. Closed integral E dot ds is equal to Q by epsilon 0, E into closed integral ds is equal to sigma ds divided by epsilon 0, and E ds means both the sides we should consider. So ds will become 2A into sigma ds by epsilon 0, and sigma ds divided by epsilon sigma A. Ds is A. So A and A will get cancelled. We will get it as sigma by 2 epsilon 0. Electric field of a parallel plate. Okay, so here two parallel plates are arranged parallel to each other. The same kind of one question we did in the check your concept. There I did the same kind of question. So one is positive charge and other is negative charge. So how the electric field will be acting? This positive charge will always move outwards and negative charge will always move towards this. Okay, so this is E positive and this is E negative direction. Okay, then for the first charge, this one E, this is region 1, this is region 2 and this is region 3. For the first region, due to positive charge, this E positive is acting outwards and towards the negative it will be acting in this direction. Positive charges and negative charges are same in number, right? So what will happen? This will become equal to 0. Okay, in region 1. In region 3, you see here E minus is acting in this direction. For this plate, E plus in which direction it will be acting? Outward direction. Right, here always outward direction, so it is acting outward. So what will be the net electric field over here? 0. Only in region 2 it will be existing. See here, positive charge means it is moving outwards, negative charge means it will be moving inward towards it. So E plus and E minus are acting in the same direction in this second region. So what will be the total electric field? Total electric field will be E1 plus E minus. So sigma by epsilon 0 plus sigma by epsilon. Sigma is the surface charge densities. Sigma by 2 epsilon 0 plus sigma by 2 epsilon 0. We will get it as sigma by epsilon 0. Okay, this is E. Electric field we got. Now, how we can find out the potential now? V equals E into D. Right, so sigma D divided by epsilon 0. So we got V E and through E we found out V. Okay, what is sigma? Sigma is the surface charge density, that is charge acting per unit area, that is Q by A into D by epsilon 0, that is V. Now we can find out C. Our aim is to find out C, right? Q by V. Q divided by QD divided by A epsilon 0. Q and Q will get cancelled, so we will get it as epsilon 0 A by D. This is the expression for finding out the capacitance of a parallel plate capacitor. Okay, understood? So these are the two parallel plates, and here left side and right side net electric field will be 0. So inside both the electric field will add together and we will get it as sigma by epsilon 0. And then we are finding out the potential ED divided by sigma D by epsilon 0, and so C is equal to Q by V. We will get the answer as C equals epsilon 0 A by D. Clear? So this is the capacitance of a parallel plate capacitor if it is filled with vacuum. Vacuum is there inside. Okay, it is epsilon 0. Epsilon 0 is the permittivity of free space. Okay, now if I am keeping a dielectric in between them, so what is this dielectric? Next, I am going to keep a dielectric between these plates. So then what will happen? Dielectric means it's an insulator. If I am keeping an insulator in between the plates, what will happen? Okay, see here in the case of in electrostatics we already learned about this dielectrics, right? Insulator means it won't be conducting, so charges won't be flowing from one point to another point. Okay, the charges will exist, they will retain there itself. Okay, now that is the reason, see, while we are combing our hair, the comb will be getting charged, or while we are, see, our hairs will be getting charged. See, or rubbing the iron. See, ironing, this iron, the press won't be getting charged. The clothes will be getting charged, right? And the same way, and in TV also. These things are insulators. Okay, insulators only will be getting this electrostatic charge. So here this in that place, if we are using any metal plate, means what will happen? It won't be getting electrostatic. Electrostatics won't exist there. What is the reason? That charge will be moving at that time itself, moving. So while we are rubbing an iron rod, so long if I am rubbing also, nothing will happen. The reason is the charge will be the charge which is flowing, additional charges. If it is getting some charge, it will flow to the ground through us. Okay, while we are holding and doing that one. Conductor. Metals are the conductors, but here we are talking about the dielectrics. That is, dielectric means it's an insulator. If I am keeping an insulator between this, what will happen? What are the changes that we are going to feel if we are keeping a dielectric between it? Next is effect of dielectric in a parallel plate capacitor. Effect of dielectric. So if the dielectric was not there, then we got the capacitance as epsilon 0 A by D. Okay, so how we came to this conclusion? First we found out the electric field. So if a dielectric is present inside that, so what will happen? As I said in the case yesterday, that positive, this is positive charges and negative charges. So charges will be, electrons will be moving from this side. Electric field is moving in this direction, so sigma, and here it is moving in the opposite direction. Okay, EP. E minus EP will be the net effect of electric field. Same way, charges, how we can find out? Net effect of charges will be sigma minus sigma P. Therefore, E equals sigma minus sigma P divided by what is epsilon 0 into K, because here K is the, since a dielectric is between these two plates, okay, positive and negative plates, a dielectric medium is present, that is an insulator is present. So it became sigma minus sigma P divided by epsilon 0 into K. So here this and all I already explained in the previous video. Okay, sigma by epsilon. What is sigma minus sigma P? Is the surface charge density. Okay, net surface charge density. That one we can represent it as Q by A into epsilon 0 K. So what is this K? Okay, K is called as, see, or epsilon 0 into K is called as permittivity of medium. Permittivity of medium. Clear? So epsilon 0 into K is called a permittivity of the medium. In some of the textbooks, instead of K, they are given as epsilon R also. So in any way you can represent epsilon 0 into K or K epsilon 0 into epsilon R also you can write down. This is called a relative permittivity. Relative permittivity. Okay, this is epsilon R. Okay, now instead of epsilon 0 into K, we can, if you want, we can represent it as epsilon also. So epsilon 0 into K, I am representing it as epsilon. So here the rest of the things. So E equals K divided by Q divided by A into epsilon. Okay, now what we should do? We should find out V, E into D. Q D divided by A epsilon, and C is equal to Q by V. So what we can write down? Q divided by QD divided by epsilon A. Q and Q will get cancelled. Epsilon A divided by D. Or we can write it as epsilon 0 into K into A by D. This is the permittivity of a, capacitance of a parallel plate capacitor if a dielectric is present inside. So simple. So dielectric relative permittivity also will be included over there. Epsilon 0 into Ka by D. Okay. So from here itself we can understand. See, sigma minus sigma P is always a positive quantity, right? So it will be a value which is more than 1. So epsilon 0 will be always epsilon will be, K is a value which will always greater than 1. While we are considering vacuum, so this permittivity of this K value will be equal to 1. Okay, so K value is equal to 1 while we are considering vacuum. C equals epsilon 0 Ka by D. But in the case of vacuum, this K will be equal to 1. Okay, and in other medium, in all other medium, K will be greater than 1. Okay, clear? So that is why in the case of vacuum, there is no medium in between the capacitor, means it will be equal to epsilon 0 A by D. If any medium is present, means epsilon 0 into K into A by D. So presence of a medium is increasing the capacitance of a parallel plate capacitor. Okay, presence of a medium increases the capacitance of a parallel plate capacitor. Clear? So next we will do some numerical based on this. So these are the formulas that you should by heart in the case of a capacitor: parallel plate capacitor, spherical capacitor and cylindrical capacitor. In our textbook only parallel plate capacitor is there, but in some of the exercise questions they asked for spherical capacitor also. So just by heart the formula: 4 pi epsilon 0 into RA RB divided by RB minus RA if RB is greater than RA. This RB and RA are, I told you the spherical capacitor means it is the two capacitors in spherical shape. Okay, so these will be the, so if this is RA and this is RB, okay, then capacitor will be equal to 4 pi epsilon 0 RA RB divided by RB minus RA. Okay, so while we are considering if RB is very much greater than A, then at that case we can avoid all these things. Okay, so that one I will tell you. See, if RB is very much greater than RA, in that case, if that is the case, then we can consider 4 pi epsilon 0 RA RB divided by RB, no need to consider, RA RB minus RA, no need to consider because it's very much greater, right? So RB and RB will get cancelled and we will take it as 4 pi epsilon 0 into RA, smaller value alone we will consider. Okay, many cases we are doing in that manner also. So now we will, so and then don't forget about C value, general equation, C is equal to Q by V. That also important formula only, right? So shall we do some questions? First one, 8 identical spherical drops, each carrying charge 1 nanocoulomb, are at potential of 900 volt each. All these drops combine together to form a single large drop. Calculate potential of this drop, of this large drop. Assume no wastage of any kind. Take capacity of a sphere of radius R is proportional to R. Okay, so this is a previous year sample question paper. Okay, so I told, right, spherical capacitor questions can come. So this one we will try. So here we are considering small droplets. 8 droplets are there, each having 1 nanocoulomb is the charge of each drop. Okay, and potential is given as 900 volt. We need to find out potential of large drop. Potential of large drop we should find out. Okay, here in the question itself it is given capacitance is directly proportional to radius. Okay, because how we are getting that one spherical case, I told you just now, I told you C equals 4 pi epsilon 0 RA, like that it will come, I told you, right? So there in this case capacitance is directly proportional to the radius of the sphere. So that one you keep in mind, capacitance of a spherical capacitor is directly proportional to radius. So here 1 nanocoulomb is the charge. So C is proportional to radius. Small r for small spheres and capital R for large spheres. So C equals K into R. Okay, potential of the drop V is equal to Q by C. Okay, so Q we know it is 8 nanocoulomb. So for the small charge, this small sphere only we are finding out, right? So 1 into 10 to the power minus 9 divided by K into R. that is equal to 900 volt. Okay, so Kr will be equal to 1 by 900 into 10 to the power minus 9. Now we are finding out for the large sphere. Large sphere means, see, each sphere, this volume, that is adding together and becoming a large sphere. So total volume will remain same. So 4 by 3 pi r cube will be equal to into 8. This is for one sphere, and 8 spheres means into 8 will be equal to 4 by 3 pi capital R cube. So we will get it as R cube 8 equals R cube, or we can write R2R equals capital R. Okay, now we can find out the value of this large potential. V is equal to Q by C. How we can find out Q here? Q is 1 into 10 to the power minus 9 into 8 divided by C is proportional to radius. So K into capital R. This is the large potential. So, or we can write it as V dash. Now that is equal to V dash we need to find out. Okay, so KR, K into small r equals 1 by 900, that is 10 to the power minus 9, right? So here instead of this we can keep like this only. This is equation number 1 and this is equation number 2. And I am dividing 2 and 1. 2 by 1 equals. So V dash divided by 900 equals 1 into 10 to the power minus 9 into 8 divided by K into capital R into taking the reciprocal and multiplying 1 into 10 to the power minus 9. So this and this will get cancelled, K and K will get cancelled. So we will get it as V dash equals 8R divided by capital R, that is 2 into small r into 900. We are getting it as 360. This much voltage. Okay, clear? So while in the question, nowhere they are telling, only the capacitance is directly proportional to radius. That is the only clue which we are getting to find out the potential. Okay, so here one sphere is having 1 nanocoulomb charge and each one is having a potential of 900 volt, and potential of large drop we should find out, but in the question itself they are telling, assume that the capacitance is directly proportional to radius. So we can take that equation and find out for the potential for V is equal to Q by C. Find out the potential for a small drop, and same way we can find out the potential for large drop. So why we are taking this one? Because we need a relation connecting capital R and small r. Otherwise it will stuck here in capital R and small r. That is why volume is equal to equals, and we can find out V dash value easily. Next one. 2 parallel plate air capacitors having their plate areas 100 and 500 centimeter square respectively. If they have same charge and potential, and distance between the plates of the first capacitor is 0.5 millimeter. What is the distance between the plates of the second capacitor? So here it is given, the 2 parallel plate air capacitors having their plate area A1, A2, 100, 500 centimeter square. If they have same charge, Q is same. Okay, if they have same charge and potential, Q and V are same, and distance between the plates of the capacitor is given as 0.5 millimeter. What is the distance between the plates of the second capacitor? Clear? Shall we do? So here 2 parallel plate capacitors are there. A1 equals 100 centimeter square and A2 equals 500 centimeter square. they have same charge and same potential Q1 or Q and V. Okay, they have same charge and potential, and distance between the plates of the first capacitor is 0.5 millimeters. Okay, so D1 is 0.5, we need to find out D2. For the parallel plate capacitor, we know C equals epsilon 0 A by D. Here it is given Q and V are same. We know C equals Q by V. If Q and V are same, then C will be same. Then we can write it as this will be C is equal. Okay, so C1 will be equal to C2. So epsilon 0 A1 divided by D1 equals epsilon 0 A2 divided by D2. And epsilon 0 will get cancelled. A1 is 100 centimeters square 10 to the power minus 4 divided by 0.5 into 10 to the power minus 3 equals A2 is 500 into 10 to the power minus 4 divided by D2. So this will get cancelled. So D2 will be equal to 5 into 0.5 into 10 to the power minus 3. So we will get the answer as 2.5 millimeter. So these are only 2 questions I did. I know some limitations are there for me also because I am getting only half an hour. If I have more time to spend with you, I would have done the more questions. So today's check your concept also, you please try, and this formulas you don't forget about the C equals epsilon 0 A by D, the derivation we learned, and this is not in your textbook. Please go through these 2 formulas. Okay, this is easy. 4 pi epsilon 0 RA RB divided by RB minus RA. This is 2 pi epsilon 0 L divided by log RB divided by RA if RB is greater than RA. Okay, so I think this is clear for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.